Hello, this is Himanshu, and about me, I'm a senior data scientist at Nationwide Building Society, and I'm here to talk about no labels, no problem, basically doing machine learning with unlabeled data. This is more general topic to not just to financial crime, but various kind of subject areas where machine learning can be applied. But at the same time, we do not have any form of labeling processes to make it work in the form of more accurate supervised set of problems. So yeah, I'll start. Just a little bit of general information that, this is based on my experience across working through multiple industries and not just about any specific case within Nationwide. As far as my experience goes, I've worked in financial services, including multiple companies, software automating companies, and in vehicle manufacturing. Across all areas, I've been in analytics and data science. Cool. So the very first question that comes is why we don't have labels. While there has been there's a great advancement in the terms of generative processes, still there is in terms of accuracy and in terms of the real outcomes, still the supervised learning approaches takes a big lead, and for that we need the labels. Basically the target variable or the outcome on which we want to model our hypothesis. So there could be possible reasons. One could be that there is no collection processes applied in the organization. One of the very usual cases, there's so much IoT data that is getting available, but if you want to identify that there's a certain change in the the functionality, or for example, if within the house data, if certain valve is fused or a certain circuit is gone bad, we don't know when it went bad. We may know the behavior, but we still don't know exactly when it happened. There is always with the way of approaching businesses with machine learning, there's always new proposals and propositions coming along, and for which we still don't have the outcome data available historically. Similarly, maybe in the organization, there's no expertise of how to gather that kind of data, and that's why the collection never started. So when are the scenarios when typically we don't have labels? And just to give you an idea of a few things, I already talked about Internet of Things data. This kind of problem exists in natural language processing, where we are trying to find out from sentiments to the kind of the overall describing the summary of a paper or an article. We don't have labeled data many times, though there are deep learning models. Still, there are a lot of scenarios where we do not have any kind of labels available for a specific problem that we want to solve. And that thing has got amplified with a lot of data that can get produced every day. So, okay, so before we move into what is the specific ways of we can create some data and use it effectively in the modeling, I think the first thing is in supervised modeling, what we try to find out. And so I just want to give a connotation about the VC dimension theory, where we try to find out that for a given error in the model, how you can estimate how much data would you need, and that is inversely proportion to the error and directly proportion to the amount of cardinality in the data. And I'm just bringing that point. What I'm trying to say here is that a lot of data is needed, generally speaking, for creating a very effective model. But that brings to a question that, is there a way to label this data in an adaptive way that can really help in accelerating this process? So, and that's what we're trying to identify, that, okay, yes, there is an unlabeled data available. In a poor man's approach, maybe we can try to label whatever the data is available, but it's expensive. You need people and the amount of time. Sometimes developing the processes around it is also very difficult, so that is not scalable. So how we can actually use some kind of adaptive decisions to do that? Because in the end, our goal is to, for a certain kind of outcome, we create an accurate classifier with minimal cost. So, and that's where it comes to the fore the active learning, where we want to find out certain data points that we want to label in a way which is intelligent. And that comes down to using selective sampling. But how do you want to sample? There are so many ways to sample the data. So on that line, there are many flavors of the active learning, but I want to highlight the predominant ones. The top threes are the uncertainty sampling. And I think it comes down from the point that learning is maximized when you are 50% wrong. So if you look at in terms of the information theory, the information contained in a binary target variable is maximized when its mean is 0.5. And this is from the Shannon's information theory way of defining entropy. So one way is that you use the current classifier to find out the specific data elements or the data rows or data attributes where your classifier is most uncertain. It could be, in case of a binary classifier, it could be probabilistically around 0.5 because that's where the entropy is maximum. But it changes with multi-labeled classification and in other problems. Another way is to approach it using information-based loss function. And here also, basically, we are trying to optimize the loss function to approach the maximum error rate or maximum information that can be gained by identifying the label of that specific data row. So we can, on that end, we can maximize the KL divergence, which is basically between the posterior and the prior, or you can minimize the entropy between the posterior and prior, or you can, if you have a model, you can find out, okay, with a specific model, where is the model entropy is actually reducing highest, so that you can use that as a way to find out that account or that row, that ID, and understand the labeling of that and try to label that data instead of all. There's another ways of querying it by committee, which is essentially building multiple classifiers at that end and querying based on the level of agreement in terms of the overall entropy available across multiple classifiers. So this is basically, it's more like an ensembling approach towards identifying through different algorithms rather than just focusing on the one algorithm. So these are the few ways we can do active learning approaches. So I want to start with one of the use cases which I've used in the past, where we went through using this selective sampling using active learning and created some form of outcome for the organization. So I think in various scenarios, generally the focus or the goal is to find out a high stakes, high commercial value outcomes or the labels that can be used to find a certain account or an ID or a customer whose labels can help us in improving the model. It could be in terms of regulatory processes in finance, it could be about avoiding risk, or in the areas of financial crime, it could be from money laundering to mules to, right now there's a cryptocurrency thing also coming across, so all kind of possibilities are there. But just as you can think, if there is any kind of financial crime happening through cryptocurrency, there might not be much historical data available. So you want to find out a group of people and identify those first. The second aspect is you want to estimate the size of the problem. In my scenario, it took us few weeks to actually create a way to develop an initial model through which I can estimate how big the problem is or how big the overall opportunity is. And the third thing is creating a model which has a feedback loop attached to improving the model based on already the new feedback that is coming. So in this process, you are developing a good model, at the same time developing a machine learning pipeline, which can be used to perform the feature engineering in a way which does not take much of your time, and identifying the new features and keeping your stakeholders informed. So how we did it in practicalities, because there's a lot of aspects here we're talking about. Maybe we are talking about, first of all, stakeholders, data engineers, data scientists, but I think the whole process can still be conceptualized in terms of three main elements, which starts with understanding the strategy of your experiment. I think system design comes into a place very much, because how you want to sample these accounts, which kind of loss function you want to use, or the specific criteria you want to use initially to find out the seed data or the initial data on which the model will be built is very important. And that needs a very engaging conversation with the customers to share your vision and your approach in a way that they can become part of it. So once you have the experiment set up where you are able to find out those accounts or those customers, you can move to SME validation, where there is a set of business stakeholders who are helping you, who understands the problem in really identifying whether this person or this customer is having that kind of behavior or not, and label that data. And the third thing is putting in the whole loop, improving your model, providing the results, and feeding it back in the whole process. So this process just builds on itself, and it becomes a self-sustainable loop in itself. So how we did it? So in our case, after a certain number of back and forth in terms of conversations with the stakeholders to understand where the business problem lies, we came up with certain data scenarios so that we can develop the initial model data or the seed data that required us to not just understand the characteristics, but also source a lot of external data, internal data, and make it available so that it can be used for not just finding out the key samples that will be validated, but at the same time, we also become part of the model, so they can be interpreted as the model becomes better over time. So in that process, we developed a set of 3,000 data points that our SMEs were able to validate. We then started a secondary learning phase with the initial data on which our model can be built. We started finding out the high uncertainty areas where there is a huge more learning available. And this was done on the basis of identifying certain features which seems important and maybe not coming too important, or there is a subspaces in the whole data space where there is a learning possible. For that, we perform a lot of machine learning interpretability and feature analysis. And based on that loop, we've identified few more customers, found out whether they seems to be the case or as a label as a 1 or 0. And based on that, we updated our probabilistic estimation of those and share the overall size of the problem also. So once again, from the practical standpoint, the operation definitely begins from the business strategies and the priorities versus finding out the problem on your own. The whole business process was validated and improved. And I think that's the nature of the whole test and learn mechanism, where you want to iterate over time. In the whole process, apart from that, there are also some ancillary areas or sub-projects may happen, and that happened in our case where we developed more experiments for the purpose of transforming the business in a positive way. This built-in feedback loop that we developed was finally included in the final production model, which was moved to a MLOps team and to the final system for constant learning and reevaluation. And the story continues. In practice, after the fact, when we have done it, if there are a few things I could take away from this project is, and those would be, start by convincing your stakeholders for real. Because everybody agrees in principle and understand the ideas, but when it comes to actually running suboptimal operations initially, when the focus is not on the low-hanging fruits, the cases where the chances of finding the outcome is very high versus looking into the areas where the uncertainty is high, leads to a kind of leads a skillful navigation of setting expectation. At the same time, for us as a data scientist, the big key learning is to be confident that this is the right choice, because that's how in the long run we will be able to maximize the gains. And there happens sometime that we are blamed for thinking too far and maybe not focusing on the immediate goals, but I think that is the way the process is set up. So that kind of communication is needed again. At the same end, I was supported very much with a team of skilled, responsive, and adaptive data scientists, because this process is very much driven by experimenting through various hypotheses, understanding the data and finding out the areas where the model can further be improved. And because the whole point here is to respond and rebuild the system based on those early feedback and take your learning from there. Yeah, that's it from my side.